So in this video, we're going to talk about the magnifying glass. Now, what is magnifying glass and what is exactly a function? Magnifying glass magnifies the image. Magnifies the image. It is also known as the magnifying glass magnifies the image. A simple microscope. It is also known as simple microscope. Simple microscope, I would say, yeah, it's known as simple microscope, right? So what exactly the phenomena? We know that only one convex lens we get. So we only one convex lens we use at this point. For instance, this is a convex lens. Okay, the line passes through the convex lens is known as mid of the convex lens, the principal axis. For instance, this is a principal axis. Okay, so this is the optical center O. This is a focal point F, and yeah, this is an object is in between F and OF, right? So let's take a different color. So when the rays parallel to the rays parallel to the principal axis passing through the lens, it converges at a point like this, and then the rays passes undeflected through the optical center. As you can see, this is a focal point. As you can see, these rays are diverged. These rays have been diverged, right? These rays have been diverged at angle. Now you're gonna subtend or their rays something like this. Here the height of an image to obtain. This is height of an image, which is, for instance, this is A and this is B. So here, so we obtain is A dash and B dash. A dash and B dash. This is basically A dash and B dash. So this angle here, this angle is known as beta. This angle is known as beta, which means an angle subtended by an image is known as beta. Now what is here? Alpha has to do nothing. Don't consider it as an alpha. Alpha is an angle subtended by an object at a distance given the minimum distance for which you can see an object clearly, right? So 10 beta is basically equals to okay, 10 beta is equals to, this is how we are driving the formula for the magnification of the simple microscope. We know that the distance from an object to optical center is UE, which means the distance of an object, UE, right? So here, the 10 beta is equals to height of an object, which means perpendicular upon base and upon mu E, right? This is mu E. Height of an object to mu E, right? So since we know the beta angle is very small, so we know that the beta is equals to height of an object to mu E. Height of an object, let's write it properly, to mu E, right? Now talking about the angle alpha, we all are aware that it does not concern with the microscope. This is the minimum distance that we can see in the naked eye, right? So alpha is equals to height of an object to D. D is the minimum distance, right? So after cancellation, let's just move a little down so that we can a bit down so that we can see an object. See this explanation clearly, right? So the ultimately the magnification that we got is equals to D by mu E. Now what is mu E and D? Mu E is basically a distance from optical center to an object, and D is the distance from which we can see an object clearly. But the case of microscope, one thing is quite pretty obvious that for obtaining a maximum magnification, the object should form an image at D. When an image is formed at D, the magnification so we obtain is maximum, and the formula is magnification is equals to 1 plus BF. This is a formula we use when the magnification is maximum by a simple microscope, right, or a magnifying glass. But if in, for instance, we could say that for the minimum magnification and for the relaxed eye, the formula is m is equals to d by f. The image is so formed at infinity, you can see it with the relaxed eye. Because in this formula, this is something like difficult to see, or we have to get strained eyes, like some sort of this, right? So yeah, it's difficult to see an image, right? So let's move a bit down again, and I'm going to write one thing. So the magnification of a simple microscope is greater than d upon f, which means the minimum distance of which we can view through a microscope. and greater than equals to 1 plus df, and the maximum magnitude that is obtained from microscope when image is formed at d 1 upon d 1 plus df, right? So this is basically a simple line.